Today we are discussed about heat conduction through compound media, series and parallel. Heat conduction through compound medium. The compound medium is nothing but these two different materials. Now the material bars in the form of series, we are connecting seriously. Let us consider a compound medium, two different materials A and B with the thermal conductivities K1 and K2 respectively. That means the thermal conductivity of a hot end, that medium A is K1, and thermal conductivity of the cold end, the materials B, at the thermal conductivity is K2. Now the temperature of the outer faces of A and B, A would outer face and B would outer face, that is in the surface, that is the contact between the A and B, theta. Now the steady state is reached. The amount of heat flowing per second through every layer is same. Already know that. You know what is steady state temperature? The steady state temperature is nothing but the maximum energy allowed through the materials. Beyond the temperature, you would not able to change the temperature in these materials. So நம்ம steady state temperature, அதுக்கப்புறம் நீங்கள் எவ்வளோ தான் டெம்பரேச்சர் ரைஸ் பண்ணாலும் அதில் டெம்பரேச்சர் சேஞ்சஸ் எதுவும் இருக்காது. இதை நம்ம steady state temperature அப்படின்னு சொல்கிறோம். After the steady state temperature reached, steady state temperature reach ஆன பிறகு the amount of heat flowing through the material per second, எவ்வளோ heat flow இருக்கும் அப்படின்றத first we have to find. The amount of heat flowing through material A, என்ற மெட்டீரியலில் வழியாக எவ்வளோ ஹீட் ஃப்ளோ ஆகிருக்கு அப்படின்றத we have to find. That is, already know that the flow of heat Q is equal to K A theta divided by distance. Here K1 A theta 1 minus theta divided by x1. This is equation number 1. Already the general equation for the amount of heat flowing Q is equal to Ka theta by x. Here K1 the temperature for hot end A, and A surface area of material, theta 1 temperature at A, theta is surface temperature, then distance from A and B is x1 and x2 respectively. This is equation number 1. Now the amount of heat flowing through the material B, the amount of heat flowing through material B, that is, already know that from this equation you can write Q is equal to K1, here K2 A into the heat flowing from A to B. So here the temperature of the surface area of the hot end is theta, then theta 2. So the heat flowing from theta to theta 2. So you can write theta minus theta 2. Then the distance is x2. So this is equation number 2. So general equations. Now you can find the amount of heat flowing through material A and B is equal in steady state temperatures. இப்போ steady state temperature இருக்கும்போது ஈக்குவேட் பண்ணுறோம். இப்போ hence equating equation 1 equal to 2. Then you can write K1 A into theta 1 minus theta divided by x1 is equal to K2 A theta minus theta 2 divided by x2. This is equation number 3. Rearranging the above equations, that is K1 A into theta 1 minus theta into x2, this is x2, equal to, rearranging the above equation, K1A theta 1 minus theta into x2, then K2A theta minus theta 2 into x1. Now A cancel each others, then you can simplify the above equations. Now you can simplify the above equations. K1 theta 1 x2 minus K1 theta x2 equal to K2 theta x1 minus K2 theta 2 x1. Then you can simplify K1 theta 1 x2, இது இந்த பக்கம் கொண்டு வரும், equal to இந்த பக்கம் கொண்டு வரும், K2 theta 2 x1 equal to K2 theta x1, இந்த மைனஸ் இந்த பக்கம் equal to இந்த பக்கம் வருது ரைட் சைடு, K1 theta x2. ஏன் நம்ம இந்த கொண்டு வரோம்னா the common term theta இருக்கிறதுனால we are taking this side, then K1 theta 1 x2 plus K2 theta 2 x1 equal to theta taking outside into K2 x1 K1 x2. Now we want to find the value of theta. The theta is equal to K1 theta 1 x2 plus K2 theta 2 x1 divided by the denominator K2 x1 plus K1 x2. The equation 4 represents the expression for interface temperature of the two composite slabs in series. ரெண்டு சீரியஸாக இருக்கும்போது ரெண்டு காம்போசைட் மிடில் அதோடைய இன்டர்ஃபேஸ் டெம்பரேச்சர் the theta எவ்வளோ அப்படின்னு பார்த்தீங்கன்னா the equation 4. Now substituting the equation theta value in equation 1. Already know that equation 1 that is Q is equal to K1 A divided by x1 into theta 1 minus the theta value K1 theta 1 x2 plus K2 theta 2 x1 divided by K2 x1 plus K1 x2. Now you can simplify by equation K1 A divided by x1 into cross multiply பண்றோம் theta 1 into K2 x1 plus K1 x2 minus K1 theta 1 x2 plus K2 theta 2 x1, the whole divided by K2 x1 plus K1 x2. Then which is equal to K1 A divided by x1 into K2 x1 theta 1 plus K1 theta 1 x2 minus K1 theta 1 x2 minus K2 theta 2 x1, the whole divided by K2 x1 plus k1 x2. Then you can simplify, that is k2 x1 theta 1, k1 theta 1 x2 minus k1 theta 1 x2. Then you can write k1 a divided by x1 into k2 x1 theta 1 minus k2 theta 2 x1 divided by k2 x1 plus k1 x2. Then you can simplify, k1 a by x1 into common k2 x1 common into theta 1 minus theta 2 divided by k2 x1 k1 x2. Then you can simplify, x1 cancel achi, remaining a k1 k2 a into theta 1 minus theta 2 divided by k2 x1 plus k1 x2. Now divide by k1 k2 on both the numerator and denominator. Then you can write a into theta 1 minus theta 2 divided by k2 x1 divided by k1 k2 plus k1 x2 divided by k1 k2. Now again you can simplify, k2 k2 k1 k1. That is q is equal to a into theta 1 minus theta 2 whole divided by x1 by k1 plus x2 by k2. This is equation number 5. Now the amount of heat flowing per second through in a compound medium, that is 2 medium, that is q is equal to a into theta 1 minus theta 2 divided by x1 by k1 plus x2 by k1 k2. The equation 5 represents the amount of heat flowing per second through the compound wall of the two mediums. Q is equal to a into theta 1 minus theta 2 divided by x1 by k1 plus x2 by k2. This method can be extended to composite slab with more than 2 slabs. For more than 2 slabs we can find, that is the general equation for any numbers, that is n number of material also we can find by using this equation, that is q is equal to a into theta 1 minus theta 2 divided by summation of x by k. This is equation number 6. This equations you can, the general equation for n number of slabs, you can find the thermal conductivity of a compound medium. Already we have to discuss about the materials in series, the thermal conductivity of a compound medium. Already we have to find, that is Q is equal to A into theta 1 minus theta 2 divided by summation of x by k. Now we have discussed about the materials in parallel. ரெண்டு மெட்டீரியல் எடுத்துக்கிறோம், different materials. Consider a composite materials of a medium. The two different materials, one is A, another one is B. With the thermal conductivity of the material, A is K1 and B is K2. Here these arrangements are in the form of parallel setup. Now you know that the phase of the materials A and B, A in the phase of the material and B in the phase of the material, the temperature is theta 1 and theta 2. Now the A1 phase, the two phases irukum, A1 and A2, second first phase irukum, second phase irukum. Admari B la vada B1 B2, the second phase irukum, second phase irukum. Now the temperature of A first phase, that is A1, is theta 1 and second phase A2 liyum theta 1 temperature maintain agudhu. Here the area of cross sections of the materials A1 and A2. Now already you know that the amount of heat flowing through the first medium. Ena inge parallel first medium and second medium. The first medium na enadhu A. The amount of heat conducted through A. Already you know that this Q is equal to K1 A1 into theta 1 minus theta 2 divided by x1. This is equation number 1. Here only two different temperature, that is theta 1 and theta 2. In the case of series theta 1 and theta 2, the surface of the both bodies between the theta 1 and theta 2 is theta. Here rendu temperature mattum dhaan irukku, so theta 1 minus theta 2. Similarly you can write the amount of heat conducted through B. Amount of heat conducted through the body B, that is already you know that Q2 is equal to K2 A2 into theta 1 minus theta 2 divided by the distance is x2. This is equation number 2. Now the total heat flow through these two materials per unit seconds, which is equal to the sum of Q1 and Q2. That is Q is equal to Q1 plus Q2. Q is equal to Q1 plus Q2. You know the value of Q1 and Q2, that is Q is equal to K1 A1 into theta 1 minus theta 2 divided by x1 plus K2 A2 into theta 1 minus theta 2 whole divided by x2. Now the amount of heat flowing per second you can find, that is Q is equal to common term theta 1 minus theta 2 into K1 A1 divided by x1 plus K2 A2 divided by x2. This is the general equation for the amount of heat flowing per second in the parallel to the composite slabs. Now, if in case you can find the n number of composite slabs which is connected in parallelly, already know that the general equations already you have to find in series method. Now, you can find the general equation for the net amount of heat flowing per second in the composite material, which are all n number of materials. The more than 2 materials which is connected, you can find that is Q is equal to theta 1 minus theta 2 into summation of K A divided by X. This is equation number 3. This is equation number 4. This is equation number 5.